Solutions Driving Energy Transformation for Viksit Bharat 2047. For the same, I would like to invite on stage Mr. Manu Srivastav, Additional Chief Secretary, New and Renewable Energy Department, Government of Madhya Pradesh. Shiv Kumar Vepakoma, Director, Power Systems, in charge Projects and Business Development, Solar Energy Corporation of India Limited. Priyanka Paliwal, Associate Professor, Manit. Shankar San Dubey, General Manager, O&M, Asset Management, Acme Solar. Please welcome all our speakers with a round of applause. Thank you for being here with us. I request Manu sir to please chair this session.
It's a privilege to be chairing this session. I've been a part of the session in the earlier part of the day. As we understand that renewable energy is increasingly becoming energy of choice, it is not being educated merely because it is good for the environment, but also because it is increasingly viable and it is much cheaper than power that would be available from conventional sources. So if we want to run viable discoms, viable utilities, then we have to accept more and more of renewable energy. And that is the path ahead. So the reason for that is not really any regulatory compulsion or environmental concern, which it does fulfill, but more fundamentally because it is more viable, it is cheaper, it is more economical. So all the players that we have, all the discussions that we had today have been entirely focused on this aspect as far as renewable energy is concerned. So today's panel has people who are stalwarts in their own way and who have had a huge role to play to bring us where we are, and they continue to play this role. So firstly, I would request, SECI has been an organization which has been playing a very unique role in development of solar energy in the country. I mean, to put it simply, it is the NTPC of the solar world. So whatever has been done earlier by NTPC in setting up good projects, SECI has initiated that. SECI's initial journey has all along been in setting up projects and conducting bidding and allowing private parties to come and invest and set up projects with being the intermediary of power. SECI purchases power from the developers and then sells to the utilities. In the last few years, they have also been trying to set up projects on their own books. They have also moved on to EPC projects, and SECI has played a role in various categories of projects, be it solar or wind, hybrid, now solar plus battery. So SECI has a wide experience in various categories of projects. So I would request firstly to you might like to mention about what are SECI's views on how the market is changing and how the demand for energy is changing.
Thank you for the very nice introduction about the company and about me. So it's a long day. We must remember that India is operating one of the largest interconnected grids in the world, at present about 450 gigawatts. And as we move forward in our journey towards energy transition, as someone mentioned in the morning, like by 2047, when India is aspiring to become Viksit Bharat, it may go up to more than 2,000 gigawatts. And predominantly, it will consist of renewable energy because the energy transition with the net zero goals, our destination is 2070. So in this perspective, we started Manu sir has said that we started with the thermal, nuclear, hydro, and the renewable energy journey started very slowly. In the beginning, I think in the 1990s, we started few wind projects in the country. Though it was a failed kind of situation, but then nevertheless, we took the first most advantage in wind energy integration. Then slowly we moved on to solar in kilowatt range to megawatt, 5 megawatt, 10 megawatts, and now grid scale, we are talking of gigawatts. Now, as more and more renewable energy is getting integrated into the grid, the problems, the complexity of problems also is going up. For example, now if you drill into the realistic problem, the energy forecast is one very, very huge challenge. That means solar is somewhat predictable, but now we are talking of gigawatt scale projects. Even there is a cloud cover in one part of the solar park that's going to affect the generation. That means your forecasting has to be very, very accurate, where you need to integrate the satellite data. You need to use all the digital tools available at your base, AI, ML, and you build up a forecasting model which is reliable, which can fit into the requirement of meeting your DSM within the more and more stringent regime that we are entering into. So this kind of forecasting, that's a huge challenge. Still, we have been discussing this issue at various levels, at the ministry level, at MNRE, at MOP, but the solutions are yet to come by. So this is one area, very large area, where the AI tools or the digitalization tools have a role to play and address this issue. For example, in wind is even more highly unpredictable. We call it seasonal, but then even in the good wind season, you never know what kind of speeds you are going to get, which can largely affect your generation and the grid security as we integrate more and more renewable energy into the grid. So this is one solution, one area, one big area of challenge for us, all of us. And next is even the design of the schemes. Like Manu sir already said, SECI has been devising various schemes. Started with plain vanilla solar, plain vanilla wind, then we moved on to hybrids, and then we invented a FDRE, which is a kind of tailor-made solution which will have wind component, solar component, storage component, which can be technologically agnostic, or it can be a battery storage, 2 hours, 4 hours. But to give you a 100 megawatt FDRE, behind you need to install say 400 megawatts or 500 megawatts. So much of extra capacity will need to have. And the extra capacity is required to give you a stable supply of 100 megawatts, and still it will be left with some excess energy, which again will be pushed into the grid based on the grid requirement and grid imbalances that will prevail at the point of time. So this is how as more and more renewable energy getting integrated, the challenges are becoming paramount, and we need all the solutions that are at our disposal. Thank you.
Mr. Shankarshan Dubey from ACME. ACME has been an active player in renewable energy for a very long time. They have also been active in Madhya Pradesh. Even the Riva project.
Disruptive prices we gave 2.17
Yes.
for ACME Riva.
Yeah. So even the Riva project, the 3 developers had come, was selected. ACME was one of them. And ACME has always been at the forefront of taking risks and delivering projects successfully. So I would like to, there is a lot of challenge that developers have been facing lately in terms of the uncertainties they face in setting up projects. So how do you think you have been able to, because the focus of this session is on technology and innovation. So how do you think that technology innovation has been helpful in you helping address the uncertainties that renewable energy otherwise has?
Definitely. As Sir said just before, we are facing big challenges on forecasting and scheduling part. Like DSM charges, penalties have been coming on and on. And it is not like we have been negligent on that part. The developers are not negligent on that part, but the situations are such, like rain clouds. Recently, if we say this April, May, June, they are gusty wind season, but we are facing rains between every interval. So that is giving us a lot of challenges to give the correct forecasting. Although we have been deploying, apart from traditional to taking the private satellites into account, private satellites locations, tracking of their last 3 years, 4 years, tracking of those datas through private satellite owners. And we want to integrate that. We try to become more accurate, but still there are challenges, and we have been trying to resolve them at through the technologies, through the various technologies which are coming on and on. And now recently we have been into, earlier it was plain vanilla solar. Now after that hybrid came, 33 and 77%. That also we are developing. And now after this FDRE came, that is expectation is around 70% of PLF through from all three integration: battery, solar and wind. So now there are a lot of technology challenges in FDRE. Although all developers have made some models and they have won the bids, but on the developing part, they have been facing a lot of challenges, because battery technology, we have to bring it from China. That is the biggest hurdle for us, and we are completely dependent on China. Let us say there are other countries also giving it, but the price is unbeatable which China is giving. So ultimately, being a developer, we have to dependent on that. So and the challenges are on the land part also. Although Rajasthan is a big area, MP we have some of the areas where we can develop. So we are coming up with up to 720 watt peak. Proven technology has come, and TOPCon at JT modules. But still, we are working more on other base material, and other base material which can bring it to 900 or so with the same size. If the size increases, then there is no use for us. We want to bring it back. We have 1.2 gigawatt of manufacturing facility of TOPCon modules bifacial. We have developed a factory, and now it is in approved list also, approved supplier list also, ACME. We have recently forayed into this. And here our focus is on the technology, how we can develop it more precise, so that our land requirement reduces. We want to develop big solar and solar integrated hydrogen, ammonia, but the challenge is we all, for a scale of 300 megawatt of solar, we want around 1200 acres as of now. Now that with the help of technology and east-west array, we have been developing we have been trying, not developing actually as of now, on trial basis, we have been taking like 1 megawatt of solar on east-west array with the hut type structure, on trying to implement it on a large scale for 300 megawatt. This will reduce our requirement of cables, DC cables and AC cables, as well as the area of land. Currently, with the most top-notch technology, we require 2.4 acres per megawatt. But we want to reduce it 1.6. Maybe I am very hopeful that in the coming 1 year or so, we would be able to do that. We have been trying very hard, just looking after on trial basis 1 year, what challenges in maintenance operation we are facing. Once we overcome those trials, we will definitely put into that, and it will become a market norm that they will quote according to 1.6 acres per megawatt from 2.4, which are being developed right now with the south facing, or with the tracker technology. Tracker technology again is very good, but again it requires little bit more area. It gives specific yield increases, but still the area, it requires more. Now we are facing the challenges on area part, large areas, because already most of the developers have acquired area which was available throughout. Now we have to make it in patches. So how optimize we can do? This optimization is what technology we have been developing, we have been trying. We have been trying in India, we have been trying with our foreign partners. So this technology, once it proves and 1.6 acres become norm, this is what we want. And if it becomes norms, then definitely if we go large scale like 1200 megawatt in Fatehgarh, we have been developing. So if it become 2.4 acres to 1.6 acres, definitely it will be a huge advantage. And more importantly, we will get that much land. So this is on the technology part, which we have been developing to reduce our cost, developers cost, as well as a country whole in lesser area, higher plant, because it is very difficult to dismantle any plant which is already on 3, because with the technology from 4 acres we have reached to 2.4 acres, 2.4 per megawatt, and this we want to reduce it further to 1.6 with the higher rating of modules, with the top notch technologies of the module with the same size. From 85 we are going to reach up to 900 within next 1 year, means proven technology which we can install. So this is on the part of technology for solar. And wind, definitely wind still a challenge. Wind is still a challenge, because although we have been developing, we have been manufacturing 18 or so megawatt, gigawatt, 18 gigawatt here, but most of the things are getting exported to various countries. We have not been able to develop. And third part is offshore, onshore. This offshore wind, if it initial cost is more viable gap, definitely we would, developers want government to support us in the under viability gap, because installation cost is very huge, operational cost is very huge, but definitely no land requirement. And it is a sustainable solution with the proven technology if we install it. So from these two are the key critical on the technology front. And third is innovation in the operational plant. The more we optimize, the more we reduce the failures, the more we will sustain. In order to sustain, in order to have a continual growth, continual profits, to develop more and more, uh, operational excellence is very much needed, and it is very much needed. Without operational excellence it is very difficult. All kind of technologies we are using, uh, uh, like from complete digitalization of the solution of larger plants to the monitoring, each data point, monitoring of each data point from larger transformer, interconnecting transformers, power transformers, inverter duty transformers, and unit substation transformers. Because transformers, why I'm talking about transformers, are the key component which disrupt the power of complete area at one go. Whereas other components are restricted to some level. It is not like thermal plant, where if something goes wrong in boiler or something goes wrong in WTG, wind turbine area, complete plant we have to shut, like 660 megawatt. Here we have a redundancy that, okay, this 3.5 portion has gone wrong, you stop it, rest we can immediately restore. But transformer, that is why transformer is becoming a key component, which requires, and due to the price competitiveness, definitely quality has reduced. The production quality, the quality of the transformer which we were developing around 10 to 15 years back was very good, and you never would have seen the failures. Instead, the companies, government companies never used to do monthly DGA or quarterly DGA. Then also they were functioning like anything. But due to price competitiveness, definitely quality has come down, but we have to bear it. We can do it. We can sustain it through the preventive maintenance, predictive maintenance, analysis of the data. So that is what we are doing to sustain sustain and make it a profitable. Although we say it that prices are low, it is affordable, but yet if we do not maintain it properly or we do not use all these technologies, then there is nothing for the developer. They will not get anything out of running. So we reduce cost is reducing. The more challenges are on the developer side, how to sustain this cost, how to get their return on investments. So in getting the better return on investment, this operational excellence is the one of the key aspect. So these are the main things I would like to say. Thank you.
Thank you so much. You covered various issues on how to bring innovation and use technology. Now, I would request Professor Paliwal, Professor Priyanka Paliwal. I must say that what we talk of technology and innovation, I've been a witness to how her involvement has enabled that to happen. Uh, uh, we have been working on decentralized renewable energy generation. So she has enabled an innovation. She has presented it, and we are trying to implement it. Wherein the idea is that how you can use reactive power to in decentralized solar generation. So the entire idea has been developed by her, and it emanated from a report that she and her team had in Manet had developed. But subsequently, they have helped us in demonstrating it before our various power sector companies and before the regulatory commission. They're also helping us in framing the mechanism of regulatory compensation. The entire credit goes to Professor Paliwal. And I would say that this is a very unique case of, very often we talk of collaboration between industry and academia, but these are always thoughts that are spoken about but never really truly implemented. But what she's going to talk about is something that has been developed by her and her team and is being implemented, and we hope to implement in the coming few months. So I would thank Professor Paliwal for having done it and request her to please explain the concept.
So can I explain it from there, sir? I would run through a presentation also. Good evening, everyone. So at the outset, I would like to thank the organizers for giving me an opportunity to speak among the distinguished gathering. I would like to use this platform for sharing about a very ambitious and forward-thinking initiative by Government of Madhya Pradesh that has come at just the right time to empower decentralized solar projects. This is thinking beyond merely injecting power into the grid. It is recognizing the potential of decentralized solar generators as active participants in the grid management. So to give you a background, uh, for the past 1 year, the team at Maulana Azad National Institute of Technology has been working on exploring the possibility of providing reactive power management through solar inverters. We have, this was a project funded to us by World Bank. We have gone for thorough technical analysis and have also tried to extend our wings beyond technical analysis to work on the business models as well, so that the solution is practically implementable. Further, to validate the concept, we have gone for field demonstration in presence of the officials from Regulatory Commission, Transco, SLDC, DISCOMs, Power Management Company, Urja Vikas Nigam. So we have validated the concept, we have demonstrated the proof of concept at 230 kilowatt Manet rooftop solar, and recognizing the potential, a 2000 megawatt Kusum C tender includes the provision for reactive power provisioning. Further, there's pilot implementation for dynamic voltage regulation, which is underway. So the genesis of the concept, I would keep it minimum technical. The genesis of the concept derives its motivation from the traditional way of using solar inverters, generators, only for injecting active power. So at present, the inverters operate at unity power factor, which means that they inject only active power. However, the grid cannot be satiated only by active power. We have loads, transformers, lines, and they will all need reactive power. And since your generator cannot supply this, this reactive power has to be drawn from the upstream network. So when this reactive power travels from the upstream network, it creates line losses, voltage drop, and degrades the voltage profile of the feeder which is already battling with the low voltage issues. So the solution that is being proposed is that rather than operating this inverter at unity power factor, we operate it at a power factor which is deemed suitable based on grid condition. So that now it injects not only the active power, but the reactive power as well. So when we talk about decentralized generation, the currently, if we look at the scenario, it is not decentralized in its truest sense, meaning that only active power is decentralized, the reactive power still remains decentralized. With this, the essence of decentralized generation is being truly achieved because now the reactive power is also decentralized. So, using solar inverters for managing reactive power offers a plethora of benefits. This unleashes the potential within the solar inverters because they often remain underutilized because of fluctuating irradiance levels. And that is why there is enough bandwidth usually that we have for supplying the reactive power. This leads to utilization of existing infrastructure. The current practice is to use capacitor banks. So this leads to the saving in the capex investment by the discoms and provides a very effective OPEX solution. And as we all understand that the capacitor banks can only provide stepwise compensation, whereas with solar inverters, they are capable of providing smooth dynamic compensation. Capacitor banks would be able to address only the under voltage conditions, not the over voltage conditions. With inverters, we can address the over voltage conditions as well, which are likely to become more frequent as we bring in more and more decentralized generation online. So, moving ahead, we have conducted a case study for Rapora substation. I would just share the very important findings to give you a perspective. So this substation is located at the fag end of 82-kilometer long Shahanagar feeder in Panna district of Madhya Pradesh. And this hosts a Kusum generator, Kusum A generator, which is of 1 megawatt capacity. So upon analyzing the data, we found that because of the low voltage conditions, this feeder battles with persistent low voltage issues. Because of the low voltage condition, a typical problem that has been observed is that the inverter cuts off. So even though when we have enough solar irradiance available, even though when there is no outage on the feeder, the inverter is not able to inject any active power because the inverter goes into the tripping mode because of thermal overload. So just to give you a perspective, the blue curve represents the maximum solar generation which was observed in the month of May. Green curve represents the average solar generation in the month of May. And this red curve, this represents generation on 11th of May when the voltage was typically low. It can be observed that there are periods of generation, then there are periods of non-generation intermittently, and it can be seen that even when the generator is generating, the generation is not up to the mark. This is because of the low voltage issue. Now, because the inverter is getting tripped, this is directly hitting on the capacity utilization factor of the plant. As it can be seen from here, the CUF is very low, in the range of 6 to 8, particularly in the agricultural months when there is heavy loading condition. So this directly impacts the commercial viability of the plant. So this was when the inverter was operating at unity power factor. Now, when we operated the same inverter at the variable power factor in the reactive power management mode, the voltage improved. So this is the improvement in voltage. As it can be seen if you observe the Rapora substation, which is at the fag end. It can be seen that the voltage improves with the reactive power injection. We have injected 600 kVAr of reactive power. It is a 1 megawatt generator. That is the maximum reactive power which can be injected. We have also compared this with the capacitor bank. It can be seen that the inverter outperforms the capacitor bank when the voltage is typically low. So when the voltage improves, the inverter cutoffs can be largely prevented, the inverter trippings can be largely prevented. This is also the impact on feeder losses, so the discom grids also benefit because of the reduction in losses. So this is because now the inverter tripping can be prevented. This is the impact on CUF, as it can be seen that the CUF improves particularly in the agricultural months from October to December, and this has a direct impact on the increase in revenue. So this is the estimated increase in revenue. Current annual revenue from the active energy sale is 31 lakhs at present. Expected increase in revenue with the prevention of inverter tripping is around 6 lakhs. So about 19% increase in revenue can be achieved merely by operating inverter in the reactive power management mode. We're doing nothing else. Here, no incentives are being taken into consideration for reactive power. It is the improvement in CUF on account of the tripping which has been prevented. So this is a commercial analysis which we have done for 1 megawatt solar generator, considering that if the incentives are also being given for reactive power. So we have tried to stay within the confines of the IEGC regulation, which state that for every unit of reactive energy injected, when the voltage is below 97% and absorbed when the voltage is above 103%, is being paid at 5 paisa per unit. So the cost can be decided by the state government. I mean, individually it can be decided. But as of now, this is considering 5 paisa per unit. So the revenue, this is the profit with the reactive power incentives being included. If the reactive power management is kept confined to sunshine hours, the profit is around 20.5%. If it is desired that this be extended at night time also when there is no solar generation available, but the inverter can be used for reactive power management, that is the utilization of inverter, the profit percentage can be as high as 25%. So this can greatly increase the commercial viability of the decentralized solar project. This is the field testing that we have done for reactive power management, just the most important results I would be presenting. This is the impact of VAR control on voltage, which we have recorded at 1 p.m. It can be seen that with no injection, the voltage was around 251. The voltage was running a bit high on that day. And with injection, it could be increased to 255 volts. With full absorption, it could be decreased to 244 volts. So the entire spectrum is visible to us. This is Q at night when no generation was available from solar at 7 p.m. 12th of April. So it can be observed that with no VAR injection, the voltage was around 245. We could increase it up to 248 volts with full 60% kVAR injection and could decrease it up to 243.8 volts with 60% absorption. So this demonstrates the capability of inverter both during the daytime as well as during the night time. So this demonstration was done in the presence of the officials from the energy sector. So they say that one size doesn't fit all, but it seems that finally we have found that size which actually does. So this is one solution where all the stakeholders are benefited. So DISCOMs benefit because they see an improvement in voltage profile by about 7% at the point of common coupling. The grid sees a reduction in power losses by up to 21%. We have dynamic control capabilities coming into picture in comparison with capacitor banks. This is a very superior solution where we can both inject and absorb VARs, and that can be done very smoothly. And this all comes with the utilization of existing infrastructure. There is no extra investment involved. We are saving the capex investment which otherwise DISCOMs would have to make. The solar power producers benefit because this unlocks a new revenue stream from them. In addition to active power generation, they can also earn certain incentives out of reactive power which they would be selling to the grid. This prevents inverter shutdown and in turn boosts the active power injection, and thus there is an increase in revenue on account of the increase in active power injection as well. The grid benefits because there is improved stability, which is actually very important as we are bringing in more and more decentralized generation online. With this solution, we can perhaps do so with much more confidence. There is reactive power independence because now we are decentralized in its truest sense. Now, not only the active power, but the reactive power is also decentralized. And this leads to an equitable distribution of responsibility. As of now, the responsibility of providing reactive power was only with the centralized grid, but now decentralized grid would also offer a share of its role and would provide the equitable operations. So to conclude, I would just say that this isn't just about the shift of technology. It is about a vision that actually has the power to transform a solar power producer from merely a power producer to active participant in the grid management. This is a solution, this is a vision where actually sustainability meets profitability. A vision where every ray of sun not only works harder, but it also works smarter. I would say it would be a very optimistic statement to give, but the future of energy, especially the renewable energy, is here. Let's try to make most of it. Thank you very much.
So as I said that this has been demonstrated. So as we could see that the voltage actually decreased and increased with just the reactive, and it happened not only during day, but also during night. So when the solar, there was no solar, and an inverter based on solar generator could help to reduce or decrease the voltage even much after sunset and without consuming any active power. It is not that active power was being consumed and reactive power was being, with no active power being consumed from the grid, apart from the inverter losses, this was done. So this can really be very transformational, and we are working to make it happen.
Sir, are we thinking of giving the compensation or this reactive power, injection of reactive power or absorption of reactive power? Any government is thinking in direction whether they can compensate like 5 paisa or?
Yes. So we have already worked that, and we have had meetings with MPRC, and in the CTU it is 5 paisa with annual increase of 0.5 paisa. But we have done our calculations, and it would be first time to be tried in the distribution sphere, because that is only in situ. We are not talking of transmission, but even the distribution. But actually, the need for this is even more in the distribution space, because the problem of low voltage is much more endemic in the distribution sphere. In the transmission area, because all STUs, I can say especially about Madhya Pradesh, have managed through their capacitor banks, they manage the voltage level very well. And very often it is high, and low voltage is not really a challenge. But in the distribution, you go to any small town or any village, that's one common problem that is faced by everyone. So the solution is that. So what we are proposing is, what we have proposed is 12 paisa per kVRH. What we have said is that if the voltage is below 97%, then for injection of reactive power, you are compensated by 12 paisa per kVRH. And if the voltage is above 103%, then for absorption of reactive power, you would be compensated by the same amount, 12 paisa. That is our suggestion. And of course, MPRC would have to go through the process of having public hearing and all that. But this would be the first time that this would be done. And I would say that the ideal place to do it is Kusum A or Kusum C, because rooftop projects are really so small, especially the household rooftop projects, that they cannot really move the needle. Now, India has a very unique experience in Kusum A and Kusum C being fairly big projects, but at the distribution, in the distribution area. So it gives us a unique opportunity to where its impact can be seen, and where the Menet team, Professor Paliwal, had demonstrated. That was only a 230 kilowatt project. And even then, Professor Paliwal, could you just go back to the slide again, please? So you would see that the voltage increase is substantial. थोड़ा आगे है. तो in the slide, if you see, in the middle is the voltage as it was with the unity power factor, or no reactive power impact, and then they have done it on both sides by absorbing and by injecting, and you can see how the voltage changes with only 230 kilowatt. Yes, the one on the right, I think. Yes. Now you explain it better. I think they're better.
Yeah. So, as it can be seen, that was Q at night operation. There was no generation from the solar. So, in the absence of any management, the voltage was 245, 240, and 242. We injected 120 kVR. Each inverter was capable of injecting 60 kVR. So, with the injection of 120 kVR, the voltage could be increased up to 248 volts. The increase of about 2 to 3%. And when we absorb by the same amount, the voltage could be decreased up to 243.8 volts. So this demonstrates that both the injection and absorption can, and this is a very small plant, just 230 kilowatt. If this is to be done at the level of 1 megawatt, 2 megawatt, 5 megawatt capacity, the impact is going to be substantial.
So does the string inverters, currently string inverters, maybe most probably 230 kilowatt inverter is string inverter called.
Yeah,
So
these are the
are they
inverters.
coming with, is the government mandated, because for like in our plants, we are having 3.5 megawatt, 4.45 megawatt. They are coming with dual mode with complete as per grid codes. They are coming with reactive power and all facilities available. But the projects which are installed in this decentralized areas like rooftops, smaller hometowns, 2 kilowatt, 3 kilowatt, are those inverters are mandated by government that they should have reactive component also, power of reactive power injection or absorption in them?
Yes, that is a valid concern. Now, these are very old inverters. I mean, I must share this with you that these are two plants. One was installed in 2014 and the other was installed in 2017. So even at that time, these inverters had that capability. So every new inverter, that it comes loaded with the reactive power management capability. It's just that whether we use it or we don't use it. We need
Actually,
to
we need to switch
on.
it on all the
So
inverters.
in MP, what we are proposing that it's going to be dynamic voltage regulation. So we are going to have a power plant controller in place which would sense the voltage at every instant of time, and accordingly it would take a decision how much amount of reactive power is to be injected. This was done manually because we did not have any power plant controller in place, but in practical solution it would be done by using a controller which would do it dynamically.
Yeah, so
But the more fundamental point is that a project set up in 2014 and 17, where this was not even envisaged, that had this capacity. So it is not that you need any new inverter or expensive inverter. Existing inverters, even of 2014 and 17, had this capacity.
In fact, you need a lot of applause. You have envisaged it before the regulations actually came in place. That's what he was talking about. Now, the dynamically maintainable reactive power is a requirement as per the uh, renewable energy grid codes. And in fact, I was just wondering in the grid scale, what he said, now we have the inverters of 3.5 megawatt scale, where it has two ranges, that LVRT and HVRT. And if the voltage suddenly drops or voltage suddenly rises, then the machines will, if they cannot ride through, they will trip. So it will stop even supplying the active power, thus making the grid condition even more worse. So here probably you bypass that condition
Yes.
and made it compatible to the grid, seeing the grid condition whether to absorb or to supply the reactive power.
Yes.
So that is really, I mean, you need a lot of applause for this
Thank you very much.
great innovation, and that to a distribution level, which is which cannot be thought.
Thank you, sir.
And all credit to Manu sir also for encouraging and for taking up such project.
No, I was just making up for the electrical engineering classes that I did not take seriously during my BTech. So one has to learn sometimes. So I thought I should do it now.
It's a really great project.
Any questions from anyone? Otherwise, we can. it's- Okay, so I think I would we close this.
I just have one thing. This is a very demonstrated nexus between the industry and the academia. And I think this kind of causes should be taken forward further, even in the domain of IT, where we are talking of digitization and application of these for the day-to-day problems, where we can have good collaboration with the premier institutes like NITs, IITs, probably even in Institute of the computer technologies and all that. So this should continue.
And I mean, that is the beauty of this solution that, I mean, there is nothing, I mean, we didn't need a new inverter. It is just application of existing technology for that. So I think another area where we can work together is, and we're already working together, is identifying of strengthening storage in the transmission sector and things like that. So this is another area which can be very useful and transformational as to where video, and we would hope together to work on that. So I would really thank the panel. And the focus of this panel was on how innovation, how technology can bring a change, because renewable energy is by nature innovative, but we need further and continuing innovations, as has been mentioned by Professor Paliwal. ECME is doing it, SECI is doing it. So that was the focus, but I suppose this is something that continued to drive us. I would thank the panel for having participated. And finally, as this is a closing session, I would I'd like to thank APAC and the Energy Department for having organized this. Thank you so much from all of us.
Thank you to all our speakers for their wonderful insights, and to Manu sir for driving this discussion so well. I would now like to request Manu sir to felicitate all our speakers with a token of gratitude. We'll start with Shivakumar Vepakoma. We'll start with Shivakumar Vepakoma for the token of gratitude. Shankar Sen Dubey. Priyanka Paliwal. As we conclude the 4th edition of National Sustainable Energy Innovation Conclave, I would like to extend my gratitude to all our speakers, panelists, and all our audiences here. We can have a quick group picture with all of you.